Welcome to the video version of the JMP tutorial, primarily for helping students for getting through Stat 231, but JMP is very useful software that you will be using throughout your career at college here. Start out with section 1, the basics. Inputting data, adding columns and rows, and filling a column using a formula. Start out here, we'll just open JMP. I already have it open. There, it will look something like this. I want to open up a new data table, file, new, and data table there. When you open up a new data table, it should have column 1 already there. To add rows, you just right click in an empty space, click add rows. Let's throw in, say 50. There, and to put in data, just click on any one of these and put in random numbers, or well, not random numbers, but the whatever data you have. Now to fill one of these, and to add a new column, just double click on any of the heads here, or right click and new column. You can name the column, and there are some options there. I'm not going to cover many of those because they're not too important. Delete columns like that. To put data into a column using a formula, you right click it, go to formula, click there, and then you have many of these functions here. Different ways you can fill it up. You can click random, go to random uniform, and say uniform random between 7 and 15. Click apply. That column will be filled with random numbers between 7 and 15. Now you can also make populate columns using formulas that reference other columns. So we'll open up the formula menu for column 2 here, and I'll make for column 2, column 1 plus 12. Apply. Now every single value in column 2 is going to be the same value in column 1 plus 12. And that's it for section 1. I'm going to start section 2 here, or part 2, which is about data analysis. We're going to learn about manipulating a distribution, finding the area under a normal curve, one-way analysis of variance, and confidence intervals. I'm going to open some tables I have prepared for that. There. This is data from a recent project I just finished. This is the time between interruptions on a machine of a certain local business in hours. It ran for quite a long time in between interruptions, but they wanted to know about that. So to do some good analysis on that, we can do analysis, distribution, click there, Y column, and OK. Now you get this table, expand that, make it more visible. Automatically puts it into a histogram. You can change the histogram. Histogram options here can make it vertical, which I prefer. You can change the bin width here. Let's make it 15. Now, you can also get more analysis here. Look at the CDF plot. This is the probability of an event occurring over time. So at 50 hours, the probability an event will have occurred is around just above 50%. At 25 here, looks like it's around 38-ish%. At 150, it's about 90% likelihood. You can also add different things here. Get a stem and leaf plot from it. Can look at just various things on this. Now on to finding the area under a normal curve. Open up another table that I have prepared for this. There. Now to find the area under a normal curve where we have certain x values here, this formula we're going to put in here will give us the area under the curve starting at negative infinity to that x value, which would be the probability that a random number produced by that distribution will be less than that x value. So go right click here, go to formula, probability, and normal distribution. Hit this caret button twice to get the mean and standard deviation in there. For the x's, I'm going to click x values, which is this column, put that in there. Put the mean at 0 for this, and standard deviation, let's say 9. Hit apply. There. And click OK. Now you can see that the lower the x value is, the less of that bell curve you're going to have ahead of that x value. So we're going to have very low probabilities of getting any lower than these numbers. At 0, where the mean is, will of course be 50%. And then past that, you have larger and larger numbers, probabilities that the normal distribution would produce a number less than one of these x values. Right, now we're going to move on to one-way analysis of variation and confidence intervals. I'm going to open up the table I've prepared for this. We have various table that has various types and values associated with each type. This could be processing times for different types of parts on a single machine. Could be most anything really. For type 1, I tried to keep the values around 7.5-ish. Type 2, I kept them around 20. And type 3, I put all the values around 50-ish, but gave them a wider variance. Now to get good confidence intervals and analysis on this, click Analyze, fit y by x, put the types and the x factor and the values in the response. Click OK. You get a table that looks like this. Now click this red arrow, drop down, click means ANOVA, and means and standard deviation. The means ANOVA and the standard deviation will both give you the mean of everything. The standard ANOVA will give you the standard error. The means and standard deviation will give you standard deviation for each individual type. The standard error is going to be the standard error across the entire data set, which it's going to use for confidence intervals, lower 95, upper 95. And the means and standard deviation is going to use the standard error for each individual one of these to give the confidence intervals. If you want to change the confidence interval so it's not upper lower 95, you click the drop down menu here, set the alpha level to 1%, get the upper and lower 99th percentile. You can set it to 10%, or you can set it to anything you would like. The analysis of variance will also give you the degrees of freedom, which really is just the number of types minus 1. You don't really need the analysis of variance menu to tell you that, but it's helpful. That's it for section 2. On to part 3, which is fitting and finding distributions and curves. We'll look at linear regression, as well as a few other regressions, and finding correlations between different data sets. I'm going to open up this table I prepared. This table has 100 values in this column. Those values were given using this formula. It's random uniform from 0 to 10. And I don't know why it says 1 to 10 there. I'll change that. There. And enter. So that's looking good. Now to get a data set which should be correlated, I'm going to add a new column here. Right click Formula, and this this new column, to populate this new column, it's going to be the first column plus a random distribution, which is uniform from, let's see, oops, from -1 to 1. Apply there. And OK. So all of the values in this column are going to be plus or minus 1 of this column. So hit analyze, fit x by y, put one of these in the y response, the other in the x, doesn't really matter which one. Get a nice distribution here, which just by looking at it, you can tell there's some correlation. But to get a good line, hit fit line, and we'll get a straight line there. It'll give us the formula for the line here. The r square value, the closer that is to 1, the better the fit of the line. It is 0.96 here, so it's a very good fit. You can also fit other types of lines. There's polynomials here, fit special. You mess around with that menu, you can find some fun stuff. Now, looking for correlation in multiple data sets, let's add another column here, and I'm going to fill that with another entirely random data set, random uniform, from 0 to 10, and hit apply. Okay. And just for fun, let's throw in a fourth column here. So formula, and let's give it a normal distribution. Let's do it with mean 5 and standard deviation 5 as well. Hit OK. Now, to look for correlation between all of these, which there should not be any between 3 and 4 with the rest of them, these are obviously correlated because the formula for this column is based off of this column. So let's do graph, scatter plot matrix, select all of these columns and put them in both x and y, and click OK. Down in the center here is each of these columns graphed against themselves, so they will all be 45-degree lines basically there. But looking at these, you can see that there's pretty obvious correlation. Get the drawing tool out. Here you have the data grouped in a straight line between column 2 and the first column in both of those. But in column 2, but neither of those columns against column 3 here, it's just a blob of points, as well as column 4, there's really just a blob of points. There's no real apparent line, no real curve, nothing in any of these that would indicate any sort of correlation.